Good morning. I'm Good morning. I'm Vijayalakshmi from CSE, working in KSR College of Engineering. Today we'll walk this computer organization and architecture. Here we'll cover foundation, function units, memory systems, processing units, instruction execution, design insight. First, we'll see what is computer. A computer is an electronic device that manipulates information, data. It stores, retrieves, and processes data, solving problems by executing a stored list of instructions. And these are the four basic operations. The first one is accept input. It receives data, instructions to be processed, store, holds instructions and data for processing. The third one is process. It executes the instruction list on the data. The fourth one is output. It delivers the results to the outside world. So we'll see what is data and instruction. Data is a raw value and instruction is a command that tells you the ALU or control unit which operation to perform on that data. Next, we'll see what is the difference between a computer architecture and computer organization. Computer organization is the blueprint for design and implementation of a computer system, while in computer organization, it is the operational parts of a system are linked together to implement the architecture. So it defines the in a computer architecture, it defines the functional behavior visible to a programmer. That is an instruction set architecture, addressing modes, data type supported, register organization exposed to software. While in a computer organization, it defines the physical realization, control signal design, memory technology and interfacing, bus structures, circuit level, hardware details. Next, we will see the five functional units of a computer. The first one is input unit, output unit, uh, arithmetic and logic unit, control unit, and memory unit. So, together, ALU and control unit is called as a processor. They are wired through an interconnection network, so information can move between any two units as required. We'll see how the units exchange information. The five functional units such as input, ALU, memory, control, and output are all wired to a common interconnection network so that information can flow between any two of them. The input either supplies data to be processed or instruction that tells the ALU what operation to perform and how data should move to from IO devices. Next, it is an input unit. It is a data or instructions are accepted through input devices such as keyboard, mouse, touchpad, joystick, or trackball. The keyboard and mouse remain the most familiar. Modern input devices doesn't send raw signals to the CPU directly. A controller or device driver converts the physical action into a standard digital code. This is why the same keyboard works whether it is connected to a PC, laptop or embedded system. The interface is standardized even through the underlying hardware differs. The next one is memory unit. The memory unit stores programs and data. It is broadly classified into two categories based on speed, cost and performance. In primary memory, it is fast in speed. In secondary memory, it is low cost per bit. It has larger capacity, while in primary memory it has a smaller capacity. It is directly accessible by the processor. In secondary memory, it is accessed indirectly via primary memory. It is primary memory is volatile, secondary memory is non-volatile. Primary memory has electronic speed, storage cells, word organization, addressing, and word length. And it has three types of primary memory. The first one is RAM, cache memory, and main memory. The fastest among these memories are cache memory. It bridges CPU memory speed gap. Primary memory is faster but expensive and volatile. It loses all content the instant power is removed. And this is the memory hierarchy of a memory unit. And this is the secondary memory. It is the hard disk of a system. It includes flash drives, optical disk, and memory magnetic disk. It is slower and less expensive compared to primary memory and does not lose its contents even when power is switched off. It is used to store large volumes of data or programs permanently, or data that is less frequently retrieved. And it here shows the comparison between primary versus secondary memory. And next we'll move to ALU. It performs all arithmetic operations such as addition, subtraction, multiplication, division, and comparison between numbers, as well as logical operations such as and, or, and not. It executes the operation specified in the instruction and stores the result in a memory. Intermediate results are held temporarily in registers. Operands are placed into registers, each holding one word before the operation, and retrieving data from a register is even faster than from cache memory. Final one is output unit. The output unit sends processed results back to the outside world. The most familiar output device is the printer. A display screen is also an output unit. It generates results but also displays whatever input is being provided. So this is often termed as I/O unit. For example, the common output devices are printer, monitor, speakers, and plotters. Next, it is a control unit. The functions of input, ALU, memory, and output need coordination, so operations can happen in correct sequence. So accept input, place it in a memory, process the stored input, and generate the output. The control unit coordinates this entire sequence. It is the conductor of the orchestra that ensures every functional unit cooperates to produce useful output.